Hello viewers, welcome to video number 90 of the channel MALACHEMPHILIC. Video number 90 is the 31st episode of Chemical Thermodynamics. Topic of this episode is Carnot Theorem. So let's start. So topic is Carnot Theorem. From the efficiency of the Carnot cycle, we have observed that efficiency of the heat engine eta is equal to T2 minus T1 by T2, where T2 is the temperature of the high temperature source, T1 is the temperature of the low temperature sink. Okay, therefore, this efficiency of the heat engine, it depends only on the temperature of the source and sink, and it does not depend on the nature of the working substance, and that is Carnot theorem. So what will be Carnot theorem? That any heat engine or the heat engines working reversibly between the temperature or same temperature of the source and sink will have the same efficiency irrespective of the nature of the working substance present. Okay, so Carnot theorem is all the heat engines working reversibly between the same temperature source and sink, same temperature of source and sink will have same efficiency irrespective of the nature of the working substance. Okay. So all the heat engines working reversibly between the same temperature of source and sink will have the same efficiency irrespective of the nature of the working substance. Whatever, in Carnot cycle you have seen that we are taking the working substance as 1 mole of an ideal gas. You take any gas, hydrogen, helium, oxygen. If the source and sink temperature are same, efficiency will be same. And this generalization is the result of the validity of second law of thermodynamics. So let's prove it. Now, say, let us consider two heat engines. One is ER and other is ER dashed, right? And efficiency of ER dashed is greater than efficiency of ER. Okay, so I have taken two reversible heat engine ER and ER dashed. Okay, now the first condition, what it is doing? ER absorbs absorbs Q2 heat from source. Source means temperature T2. Okay. ER test also absorbs Q2 heat from source. Source means temperature T2. Okay. Now, this one ER converts a part of the heat to mechanical work. W. Okay. What ER test is doing? Converts a part of the heat to mechanical work, that is W dash. Okay. Now, what is the third point? Remaining heat. What is the remaining heat? Q1 is released at the sink. Sink temperature is T1. And here what is happening? Remaining heat. Remaining heat means Q1, and Q1 means Q1, that is equal to Q2 minus this W. Okay. And now here remaining heat, that is Q1 dash, and Q1 dash will be is equal to Q2 minus W dash is released to the sink. Okay. Now efficiency of ER dash is greater than ER. That means this W dash is greater than W because it is more efficient. It can convert more amount of heat to work. Okay. W dash is greater than W. It means that Q1 dash is less than Q1 because more amount converted to work, less amount of heat it is released to the sink. So that means this is the situation. Now, if we couple these two heat engine and make a composite heat engine, then how it will be? See, this is the source. Temperature is T2. Okay. Now, this ER dash, this heat engine, it takes Q2 amount of heat from the source and then it converts a part of it to W dash mechanical work, and the remaining heat it is released to the low temperature sink. This is sink, temperature is T1. Remaining heat is how much? That is Q1 dash, which is equal to, already I wrote, Q2 minus your W dash. Okay. Now coming to ER. This another heat engine. This ER, it is taking heat from the, actually what we are doing, let me tell you, these two heat engine ER and ER dash are coupled to form a composite heat engine in such a way that this ER dash, it works in the direct manner Okay, direct manner means taking heat from here and releasing that Q1 dash to the sink, direct manner, whereas ER is acting in the opposite direction. It is absorbing heat from the sink and work is done on it, and then it is releases heat to the high temperature source. That means ER is acting as a refrigerator. So that only I am drawing here. Later I will write it. So this ER is taking heat from this sink and then now it is releases to the high temperature source. This is minus Q2. It is releasing minus Q2. Okay. And here it is absorbing heat, that is Q1. Okay. And already I wrote you Q1 is equal to Q2 minus W. This is the situation. So, ER and ER dashed are coupled to form a composite heat engine so that ER dashed works reversibly in the direct manner while ER works in the opposite direction how takes heat from the sink. Work is done on it. And ER and it releases this Q2 heat to the high temperature source. Okay. So what we can say? ER acts as refrigerator. Now, what will be the resulting situation? See here. So, if we consider heat transfer at T2. Okay. Now, here it is. I am taking the heat engine ER dashed, then heat engine ER in the forward direction. This is forward. Then heat engine ER backward, then composite heat engine. Okay. So first one is heat transfer at Q2. ER dash is taking heat transfer at T2, that means high temperature source. ER dash is taking the Q2 amount of heat. So it is plus Q2. Okay. ER, if it works in the forward direction, it is also taking heat from the source plus Q2. But in the backward direction means it is releasing. So that means it will be minus Q2. So what will be the result? The result will be this plus Q2 plus of minus Q2, that is equal to 0. Okay. Now this happens at high temperature source. Now come to work produced. Work produced. How much? Here it is producing work, means work is done by the system. So W dashed, already I took it as W dashed, and this W dash sign will be negative. Okay. And ER, if it works in the forward direction, then it produces work W. But in the backward direction, when it is in the backward direction, work is done on it. So it will be plus W. Just sign will be reversed. Okay. Then what is this situation? Final situation at the composite heat engine? This will be, means what is the work produced by composite heat engine? That will be minus W dash plus of plus W. This plus minus sign just indicates it is work done by the system, it is work done on the system. This is the work produced. Now coming to heat transfer at T1, that is low temperature syn. Okay. This ER dash, it is releasing what amount of heat? Minus Q1 dash. Minus indicates it is releasing heat. Achha. Now ER in the forward direction, if it works in the forward direction, then it will be minus Q1. Okay. But in the backward direction, actually in the composite it is acting in the backward direction. Then backward direction it will be plus Q1. It is taking heat from the sink. So what is the result? Result is here this minus Q1 dashed plus of plus Q1. Okay. Now if we analyze this result, you see here at the high temperature source, this heat transfer is 0. Okay. And since your W dashed is greater than W, already assume that heat engine ER dashed has more efficiency, then what we can tell that this composite heat engine, the composite heat engine absorbs this amount of heat. What is the amount of heat? I can write it as this is minus Q1 dashed plus of plus Q1. And you know that Q1 dash is less. That means Q1 is more. So heat is absorbed. Composite heat engine absorbs this amount of heat, and it is completely converted to work. What is the work done? Work done is this minus W dash plus of plus W. Once again I am telling you, this plus minus sign are only to indicate here work is done by the system, here work is done on the system. So work is done by the system, this is more. Okay, this W dash is more. Already we have told that one. So this much of work is produced, and here in the heat source, that is high temperature source, there is no heat transfer. So all the heat what it is absorbed, this composite heat engine, whatever heat it is absorbing, that means this much, it is completely converted to work, which is against, this is against, again second law of thermodynamics. So therefore, efficiency of ER must be equal to efficiency of ER dashed. So ER and ER dashed both were working between the same temperature of source and sink. So their efficiency must be same, and that is Carnot's theorem. Hope you have understood. Thank you.